This is section 1 dealing with matter in this unit 2, which is chemistry of life. So we'll start by talking about elements and the periodic table. And so right up top here it says all living things are made of matter. And if you don't remember what matter is, it's anything that occupies a space and has a mass. And all matter is made of elements, which again can be found on that periodic table. They're just pure substances that we can't break down by natural means. We can break them down in like a nuclear reactor type setting, but that would be the only way. In normal chemical reactions, they wouldn't break down on their own. So when we look at the structure up here, this is an atom, and all these elements are made of atoms. And an atom has a nucleus, which is made of neutrons and protons, and then that's that kind of heavy middle part right there in the blue and yellow. And then around the outside are these electrons, and those electrons sit in what we call energy shells, and they're just kept there so that as they're spinning around that nucleus, they don't run and bump into each other. So again, taking a look at the atom, the nucleus has the neutrons and the protons. Neutrons are electrically neutral, protons are positive, and electrons are negative. So in the nucleus, protons and neutrons, and then around the outside are all the electrons, as shown in that picture to the right. To find the atomic number of an element, all you have to do is look at the periodic table, and that will equal how many protons it has. So if you look at the periodic table and you find oxygen, its atomic number is 8, so that would mean it has 8 protons. Okay, that would also mean it would have 8 electrons. So the number of protons and the number of electrons are equal. However, the neutrons, which are in the nucleus, can change, and when that happens, we call them an isotope. And sometimes the electron number can change as well. If they gain or lose electrons, those are called ions. So that's just different forms of the same element, but therefore they would react differently in chemical reactions. So a chemical compound is when we get a new substance formed when atoms of 2 or more elements kind of join together and react with one another. Okay, so they have to somehow join together using what we call a chemical bond. And there's 2 main types that we'll talk about here. The first one is the strongest type, that's called a covalent bond, and that's going to form between 2 nonmetals. And your nonmetals are on the right side of the periodic table. Those are mostly gases. That also includes the hydrogen for this one. And then an ionic bond is between a metal and a nonmetal. So all the metals are on the left side of the periodic table. All the nonmetals are on the right side. So you'd have to take one from the left, pair it with one from the right. That would be an ionic bond, which is a little bit weaker than the much stronger covalent bond. So this picture here is showing CH4, which is methane gas, and it's showing a covalent bond here between the carbon and the hydrogen. Since both carbon and hydrogen are gases, which are nonmetals, we know that it has to be a covalent bond. Plus, they are sharing those electrons between them, and that's what happens in a covalent bond. So if you look at the periodic table, which can be found in the back of your student planner, it's on reference page R13. You have one there. There's also one in the Flexbook that you can look at. And there's lots of periodic tables that you can also find online and print out too. But probably the easiest one would be to grab your student planner, go to the back, R13, and take a look at the periodic table. So like I said again, the nonmetals are on the right side of the steps. And if you don't know what the steps are, it's right here on the periodic table where the purple meets the green on this picture. That's your stair step. So anything over here, these are the nonmetals, all the gases. This far right column are your noble gases. And then these are just kind of the most prevalent gases that we find in the air and in the human body. And then the metals are going to be on the left side. So I'll go back to that picture. Your metals are all in these kind of first 2 columns, and then this whole middle section, those are all kind of metals as well, with the exclusion of hydrogen. Just because it's on the left, that actually is a gas, but it doesn't follow the rules of everything else. So that's kind of why he's up here all alone doing his own thing. So the symbol for each element is just the letter that is used. So like for oxygen, they use the letter O. The atomic number, again, they'll go in order, 1, 2, 3, 4, 5, all the way through the periodic table. That's the atomic number for each element, which means that's how many protons it has in it. It's also how many electrons it usually has. And then the atomic mass is the protons plus the neutrons. And you can find that on the periodic table as well. So again, let's look at oxygen. Its atomic number is 8. I find that up in the left-hand corner there. Its symbol is O, and its atomic weight is 16. So if I know from these numbers, I know it's 16, that's its atomic weight. That's the number of protons plus neutrons. And I know it has 8 protons. So if I take 16 minus 8, I would know then that it also has 8 neutrons. Okay, just some basic little math there. Or like if you look at carbon, whose atomic weight is 12, we know it has 6 protons. So if I take 12 minus 6, it also has to have 6 neutrons. All right, so if you actually start to read a chemical compound, it's pretty easy to do. You just look at the symbol and how many are there, so the number underneath. So this is C6H12O6, which is just telling us that there are 6 carbon atoms here, 12 hydrogen atoms, and 6 oxygen. So that little number after it's telling us how many are in there. So, and this C6H12O6 just happens to be what we call glucose. It's a very simple sugar form that's used in our body to give us energy. So it comes from food that we eat and pretty much provides the energy needed to do most life processes. And we'll be taking a look at other chemical compounds throughout this unit. So that was just one example. And it looks like that's it for this section.